To start off this math journey, our original equation is y equals x squared over x squared plus 3. To start this off, we know there's a horizontal asymptote because the numerator's degree equals the denominator's degree, so the leading coefficient of the numerator over the leading coefficient of the denominator equals 1. So the first step here is to find the first derivative, and we do that by using the quotient rule. What that is the derivative of the numerator multiplied by the denominator, subtracted by the derivative of the denominator multiplied by the numerator, and that is all over the denominator squared. When you finish the math for that, you'll get the final first derivative to be 6x over the quantity x squared plus 3 squared. And then you are going to set the numerator equal to 0, and you will get x equals 0. So then you are going to make your intervals. Then I'm going to plug in a negative 1 into my derivative and find out that that half of the function is negative, which means it is decreasing. Then plug in a 1 into the derivative, and that half of the function is positive and it is increasing. We know that if the derivative changes from a negative to a positive, then that interval yields a relative minimum. So at the interval 0, we have a relative minimum. And now we have to find the second derivative, which is another huge quotient rule, but there is also a chain rule in the middle of it. Then you are just going to multiply all of those numbers together and you'll come up with something like this. Once you have the bottom equation down there, you can use the difference of squares formula to simplify your equation. Once you plug it in, you will get negative 18 times the quantity x plus 1 times the quantity x minus 3 times another quantity of x squared plus 3, and that x squared plus 3 will cancel with one of them in the denominator. Once you clean everything up, it'll look like either one of those two. You can have it either way. And then I set the numerators equal to 0 and got x equals negative 1 and x will also equal a positive 1. And then we set up our intervals and plug in a negative 2, which yields a negative number, so that means the first half is concave down. When you plug in a 0 for the second interval, you yield a positive number, which means it's concave upward. And then you plug in a 2 for the third interval, and you yield a negative number, which means it's concave downward again. When the second derivative changes from a positive to a negative or a negative to positive, that number will yield an inflection. So you can see that we have an inflection at negative 1 and 1. Congrats, we finally finished that long problem. Now all that's left to do is to graph the function, and I would recommend graphing it on a graphing calculator for accuracy. So here is the final graph, and take note that I put in my horizontal asymptote and all of my major things we just found going through that whole process.